Scientists invent a new hybrid food by growing beef inside grains of rice. I'd like to know how they're going to preserve the meat if they grow it in the rice. You can understand how dangerous this is. As the world's population continues to grow, so too does the strain on the environment, not least among the stressors is food production, especially in vast swaths of land and water required for the cultivation of livestock. It's still in its infancy, but lab-cultured meat could be one means of easing the pressure, and Korean scientists have just found an innovative way to make it. They've invented a new hybrid food consisting of cells of bovine fat and muscle grown inside the grains of rice. The result resembles a strange combination of minced meat and rice, of pink sticky grains, but according to a team led by biomolecular engineer So-Hyun Park of Yonsei University, the mashup is rich in nutrition, and although a little labor-intensive to produce now, it could one day ease food pressure. Imagine obtaining all the nutrients we need from cell-cultured protein rice, Park says. Rice already has a high nutrient value, but adding cells from livestock can further boost it, he said. Rice is about 80% starch, with the remaining 20% being protein and other nutrients. It's an excellent dietary staple, but the researchers thought there might be a way to make it work a little harder. In biological systems, cells require a scaffolding that shapes tissue as it grows. In laboratory settings, scientists often use an artificial matrix for various tissues and organs. Park and her colleagues thought being so porous, rice could serve as the same function, acting as the scaffold on which lab-grown animal cells can build into tissue. First, they coated grains of rice with food-grade fish gelatin and food enzymes to help the cells find purchase and maximum the amount of cellular material that clings to grow on the rice. They then seeded the rice grains with cow muscle and fat stem cells and let them grow in a petri dish for 9 to 11 days. At the end of the cultivation period, the researchers tested the rice to study its structure and nutritional content. They found that the beef-rice hybrid was both firmer and more brittle than regular rice. More to the point was how the nutritional profile of the rice changed. The hybrid rice had significantly higher protein and fat content, 8% more protein and 7% more fat than untreated rice. That might not seem like a lot, but with tweaking, it could be bumped even higher. And as it stands, the meaty rice or ricey meat would be less costly to produce than beef per grain of protein in both emissions and money. Hybrid rice production, the team calculated, produces 6.27 kilograms or almost 14 pounds of carbon dioxide per 100 grams or 3.5 ounces of protein. Beef releases 49.89 kilograms of carbon dioxide per 100 grams of protein. And the cost of hybrid rice to consumer would be around 15% of the price of beef per kilogram. And the changes to the flavor profile of the rice could be interesting too. The team found that beef muscle and fat added different odor and compounds to the rice, which could be fun for cooks to experiment with. What remains now is to refine the production process to reduce the time it takes to make hybrid rice. The team may also experiment with maximizing the uptake of cellular material into the rice grains, which are remarkably receptive to the process. Park says, "I did not expect the cells to grow so well in the rice. Now I see a world of possibilities for this grain-based hybrid food. It could one day serve as food relief for famine, military ration, or even space food," she says. And the research was published in Matter magazine, and this is by Michelle Starr on Science Alert. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.